Our first opportunity here that we're going to do, thank you. Sure. The first one that we're going to take a peek at is solving by graphing. Now, for those of you that are visual, this is going to be the easiest way of going about this. Because, I just look to see where the lines cross. Where they cross, that's the answer. That's all I got to do. So, these first three up here, they're already graphed for me. It'd be nice if they were always already graphed for me. You know what I'm saying? So I look here, I look at the first one. Where do they cross? They don't. So, let's see here. That's called no solution. If I ever graph two lines and they never cross, well, there's no answer. They're never going to cross at all. What we're attempting to do is find the ones that do cross somewhere. And wherever that spot happens to be, that'll be our solution. We'll get into understanding why that is in a minute here. What's that coordinate point where I've got my green dot at here? -1, 2. Because when I'm making my coordinate points, I'm always doing my x value, or how far I go left or right, first. So if I start here, go left 1, and then my y value is second. I go up 2. Put a dot. So that's how I mark what that point's going to be. And the order does matter. I can't put 2, -1, because that'd be over here somewhere. Now this bold one's kind of weird. It's my way of saying both lines are on top of each other. So if it ends up being, and this can happen sometimes, that you get two lines and you get them into y equal and you get the exact same equation, they're the same line, we call that all reals, or if some of you like to be more artistic with the way you put an answer, you can also use this sideways 8 thing. It's called infinity. It's a way that I can get that done. Either one of these is absolutely acceptable though, but most of the ones, probably like 9 out of every 10 we do, are going to look more like this one. So there's going to be a little bit of practice to this. So if I bump this up a bit, okay, so in this next section it says, give the solution of each of the systems graphed below. So find the point number 4 where they intersect and tell me where, or what, I guess, the coordinate of that point is. 2, 3. Yeah. Well, now that'd have been close, but remember, if I did 3, 2, that would mean I go to 3 on x and 2 on y. So I'd have been close, but not quite there. So I'm always doing the x number first, and then how many I go up or down second. What about the next one? That's a no solution because they never cross. Nicely done. Perfect. Okay? And that last one, again, right, I'm always starting at 0. And since I went left 2, my x value is negative, because it's negative as I come this way and positive as I come this way on my x. And then just like Colby said, 3, because I went up 3, because going up on y is positive, and going down for 3 is negative. So I'm always just looking, and I want to put them in coordinate points like that. I don't want to put separate numbers for each one. So I can do it visually with this. Now I do want to introduce you to something that occasionally can pop up. And we're not going to do all of these, but just to kind of see how this works. Is the given ordered pair a solution? Like, but they didn't give me a picture. How am I supposed to know? Well, here's how we do it. Remember that if this is x, and this is y, and that'll be the case every time with these, what we're going to do is we can plug those numbers in and see what comes out. Now here's what I always like to do. I always like to do the x number. And I'm going to plug it in where the x is at, and then I'm going to see if it gets the y value that I want. So like here, I'd have -3 times 2 plus 7. And again, and I keep saying it, and I'm hoping some of you believe me, and because I'm being honest when I say it, you've got to make sure you know, go to the calculator if you want to. If you're not sure on this one, it's okay to type in -3 times 2 plus 7 and see what the answer is. The answer I get is 1, which is the y value, okay? It checks out. I just do the same thing on the next one then. I'm still plugging in the x, which is 2. And if I can do it off the top of my head, great. 2 times 2 is 4. 4 minus 3 is 1, which would be my y, and that checks out. So, yep, this one works. And that's the tricky part with this one. Because when I'm doing these, it has to work for both. If it only works for one, nope, doesn't work. If it doesn't work for either of them, well, that's kind of common sense. It's not going to work. But that's how these are going to go. But as I'm doing them, so like here, again, it's my x and my y, but this is the one I want to plug in, the -1. So I'm going to just kind of shoot this one out here. So I'm going to plug in the -1 for x. So -1 minus 6, because I'm just substituting where the x goes. -1 minus... What's that? I'm kind of wondering too here. So let's see, -7. Okay, the first one works. You think the second one might not though, huh? All right, let's check this out. So I plug the -1 in where x goes. Yeah, 2 definitely does not equal -7. Since that one doesn't work, this whole thing is going to be no. I know it works for one of them, but I can't say yes and no. I can't say, yes, it works for this, but not this one, because I'm looking to see is that point on both of these lines. So if you get both, it's yes. If it only works for one, though, then it's going to be no. And I want to do one more here because there's one little catch that we haven't talked about yet. So I'm going to swing this over here. So let's see here. X and Y. So there's my X I'm going to plug in. Now you're looking at this time, you're like, well, wait a minute. X and Y are on the same side. It's not Y equals anymore. Good catch in that case, because here's what we'll do. I'll stick in the 5 for X. I'll stick in the 1 for Y. I'm just doing some straight substitution. Does 5 minus 1 equal 4? It certainly does. So the first one works. Okay, let's see. I stick in 5 for X. And when I stick in the 1 for Y, it's just for the Y, so it doesn't get rid of the 2. And Colby, I think you're right. 2 times 1 is 2. And last I checked, 7 equals 7, and they both work. So I'm just going to substitute the numbers in and see if the two sides equal. If they do, great. But if you get fortunate, I guess I'll say sometime and the first one doesn't work, I don't even have to do that second one. It's just about working on getting that set. But I'm always working on doing it different ways. Actually, I do want to do one more of these. Number 10, because it's another one that's different. Okay, they give me a point. Now this time I see the y equals is here. So I'm like, okay, y is -1. X is +1. So does 1 minus 2 equal -1? Yes. Oh dear. It's not that big of a deal.
1 minus 2.
1 minus 2.
Oh, yeah.
Well, so once I check that one out, I got to do it again down here. So I take the x. The x number is always the first one. Y number is always the second one. And then I got to see if 1 plus -1 ends up being 0. And it does. They both check out. It's a yes. But I'm just plugging the numbers in, and I'm either letting my brain do the work on some of these short ones, or I'm letting the calculator take over for me. Okay? We won't do a lot of these, but it's always a way to check and see if you've done things right, if you're not sure if your answer works or not. It's just a good backup plan. So as we head to the back, now I won't do this to you real often either. I put all the graphs on one line. Now why the heck would you do that, Hardy? I'm asking myself the same question in retrospect now. Yeah, I'm with you. So we're only going to do a few of them this way, and then we're going to start doing them in a little smarter of a way down at the bottom here. So y equals x minus 4. Okay, so that's this line right here, because I see the equations on it. So I'm just going to keep that in mind. Y equals negative x minus 2. Let's see. Okay, so here's my first line. Here's my second one. Looks like they cross right here, because here's the one line, and here's the other one. What point is that? And I sort of have to work my way through all the mumbo jumbo here, because here's where my graph starts. Here's my origin, my 0, 0. So to get here, okay, I went right 1, which is 1 for my x, and I went down 3. Excellent. 1, negative 3. And so what I would do on all of these, if I were to do all of them, which, like I said, again, we're not. We're going to pick a few here and try them out. Let's see here. 2x plus 4. Okay, so this line, and negative 1/3 x plus 4. Okay, in this line. So where do they cross? Right there. So what point? I think that's 0, 4. I didn't move left or right, so I agree with the 0. 1, 2, 3, 4. I'm with you. 0, 4 looks like a good answer. You're like, okay, kind of see what you might be up to with this. All right, let's just do one more here, because then we'll do it the real way here. I'll call it the real way. So y equals x, let's say, oh yeah, so we got one line here, and negative x minus 2. Oop, right there. Start here. 1, 2, negative 5, okay. 1, 2, 3. Because again, my left or right on my x is always the first number. I went left, so it's negative, good. And then up 3, perfect. So what you're like, okay, well, if they're going to give me the lines on all of these, this isn't going to be so bad. But we're not always going to give you all the lines. And that's kind of the catch here. So here's what we're going to do. And I'm only going to do a couple at the bottom, because I'm going to do a couple on the homework with you too, because I want to give you a good start. We've only got a few of them to do on your own this first day. And then we'll kind of build on it. As I come down to the bottom, I'm going to cheat and peek at something over here. Okay. This first day, I'm going to help you out with a couple of things. We'll build tomorrow, make it a little trickier. My lines always got to be in y equal form, okay? So we must be in y equals before we graph anything. And we're going to talk more about that tomorrow, having to get y alone. We did that a little bit when we were graphing in the last unit. For now, though, I'm going to do it for you on these, because I want us to get practice with the graphing more than anything. So here, okay, my line A is going to be y equals negative 1x plus 4. And my line B, and this is why I had the direction up there to grab a colored pencil or something so we can see the difference in our lines here. We're going to have y equals 3x plus 0. And we have to graph both of these lines to see where they're going to cross each other. So I take a peek at this and I go, okay. My first line, now how do I graph a line again? I got to remember. Oh yeah. the number on the end, my y-intercept, is always what I'm doing first. That if you actually were to have seen how I was solving that, and I'll show you here. My original equation is x plus y equals 4. If I wanted to get y by itself, I need to minus this x from there, right? So if I minus the x, to me when I'm doing slope, I like to see a number. What number's in front of a variable if I don't see one? It's 1, right? So I've got the negative there, which would make it negative 1x, and then plus the 4. But that's a good question. I'm glad you asked, because we're going to talk more about that as we start doing more with the graphing. So what I'm going to do here now is my first dot's typically going to be on this line somewhere. Positive 4 means I go up 4. But if my slope, this guy, is negative 1 over 1, and I'm not using my own chart, way to go, Hardy, I'll do it for number 23. What's a slope of negative 1 over 1 mean? Okay. Yeah. Down 1. Now, I heard over. What direction's over? To the right. Okay. So from here, now this may be strange to some of you too. I'm going to go down 1 and right 1, and I'm going to do what I call going dot crazy. I'm going to keep making dots going down 1 and right 1 until I run out of room, and I'll explain why this is going to be in just a minute. We want to be so accurate with our lines that sometimes even using a straight edge might not get me what I'm looking for. So we talked about going down and right till I ran out of room. But what if I wanted to keep going the other direction? What would we have to do then? Back. All right. So if I was going down and right to get here, if I wanted to keep going up this way, what could I do with that same slope? Reverse them. So I could go up 1 and left 1. Up and left. Up and left. And you're like, okay, do you really have to put like the 20 dots like you did? Just wait through this next line and you'll see why I'm being so particular about this. So I got my dotted line. I really don't even need to connect the dots. I have a line. 3x plus 0, my y-intercept is 0. Give me a dot. Anytime I see a slope, and we talked about this before too, that's not a fraction, I'm going to make it 1. I'm going to put it over 1. So 3 over 1, what direction am I going to head? Okay, up 3, hey, and right 1. Look, I'm going over the dot already. And the reason I make so many dots is so I don't miss an opportunity like that. Now I could go ahead and complete my dots. So right and, up and right. I could also go down and left. But remember, the whole key is to say, where do the two cross? Wherever that point is, where they share a point, which in this case is that point right there, that's my answer. So for instance here, what's my answer going to be? What's my coordinate at that point that I got the arrow? 1, yep, 1, 2, 3. And I'm ready to go. So now I'm going to do that one more time with you on 24, and then we're going to work on a few problems of the homework together. Because I always want to try to keep this as simple as we can here. 24, I'm actually going to use the little chart that I made at the bottom and not ignore it like I did this time. So here, okay, for my first line, my one step would be to add the 2x over. So my first equation would be y equals 2x plus 8, because it's always got to be in y equals before we graph it. The second one, I'd minus the 2x over. So I'd have negative 2x plus 4. And those are the two lines I have to graph. and see where they cross, if they do. So I'm always going to do my y-intercept first. So on this one, that's at 8. So I'm all the way up here, because my y-intercept is 8. So let's see, once I have that point, I need my slope. What's my slope for this first line? What number's in front of my x? 2, or we like fractions, so 2 over 1. And what's that mean? Up to right 1. You're like, oh crap, up to right 1, I can only do it once. I'm out of room already. How do we fix that? Go the other way. So instead of up and right, I'm going to go down and left. Down and left. Down and left. And you're like, oh my gosh, Hardy. That's a lot of dots. Well, we're going to be thankful like the graph isn't like 20 by 20. That would get kind of crazy. But actually, the dots make the line for me. Again, I just don't want to miss out on a chance. So once I get that dotted out as far as I can where it looks like a line, I'm going to do the same thing with, in my case, the red one. My y-intercept, the number on the end is positive 4. Get that in there. My slope now is negative 2 over 1. So the only difference is, well, now that that's a negative, it means I go down 2 and right 1. You're like, well, wait a minute. Hardy, I'm not going to cross it going this way because the line's up there. Well, okay, let's stop and head the other direction then. Opposite of down and right. Up and left. Up to, oh, bingo, 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 bingo. That guy right there. What point is that right there? Negative 1. I went left 1, and I went up 6. And that's my answer. And that's the deal with all of these. Once they're in a way that we can graph them, just graph 2 lines, see if they cross. If they do, we find a point. If they don't, we say no solution, more than likely. Keep this handy, because as we, and I'm going to get you kicked off here on the front of the other sheet, just so we make sure we got this all good. So let me move this over to the side here. Okay, and here's our practice. And like I always say, it's a good idea to label things, because even though we got the board in the back, it always helps you to know, what we already do this one, which one's this go with? So this is our first assignment in homework check number 2, which again will be next week. And what my job is going to be is, these are already in y equals. Well, that's nice. So what my plan now is going to be is, I'm just going to graph these and see where they cross. So I'm going to do the first 2 here on the front with you together. Get you some direction, and then it should be in pretty good shape to knock the ones in the back out. So all right, graph the line y equals 2x plus 5. So we'll start with this one. What's my y-intercept? 5. Okay, here's my y-axis. First dot almost always is going to be on this up and down line here, this vertical line. Big old dot on 5. What's my slope? Yes, 2 over 1, up to right 1. And again, if you run out of room, just do the opposites. So down and left, left, down, and left. Go crazy, go crazy, go crazy. So just about make it where you got a line, it's just dots instead of having a line through it. If that drives you crazy, just draw the line through is fine. And then I start over again for the next one. Maybe I use a different color line, which is why, again, I had you pick those up, because sometimes if something goes wrong, then we can see where it went wrong a little easier. My y-intercept's at 2. Again, that first dot, somewhere on my y-axis most of the time. So what's my slope this time? I don't see a number anywhere. -1. So my slope tells me I'm going to go down 1 and right 1. And again, some of you may start making dots. You're like, wait a minute. Again, Hardy, this is not going to get me closer to that. Okay, then let's go into reverse. Up, left, up, left. Oh, there we go. I'm even going to stop at this point because I see the one I want. There's the point I'm looking for. But the question becomes, what point is it? I start at 0, and that's where I'm trying to get. How many do I go left or right? 1 left. If I go left, it's negative. And then how many do I go up, since that's what it looks like? 3. And that's my answer. Because I'll show you some neat tricks as we get a little further along here on some things we might be able to do with the calculator to help us. But we always want to get the basics down first, and then we can start seeing how this is going to work for us here. All right. One more, and I will put you on your own for the back, which I believe means you're going to have all of 6 problems to play with on your own here. All right. Well, that's it. Oh, that's right. I forgot. I messed this thing up originally. We got to fix this. My fractions didn't show up. Just the fraction bar did. Those are supposed to both be 1/2s. So I look at the first one, and I say, okay, the y-intercept's here on the end. It's -5. I can't lose the negative, because that'd change my answer. It's negative, so I go down. Put a big old dot. My slope is 1/2. Up and right. Up 1, right 2. Bless you. And if I run out of room there, just opposites. Down and left. Ooh, that's a lot of dots. Lots of dots. And then I just change it up for my other one. So again, y-intercept. From that, you do your slope till you run out of room. And then we do the other one. That'll start at 3. And my slope is 1/2. Up 1 and right 2. And then I do my down and my left when I run out of room. That's kind of weird. Where do they cross? They don't. No solution. So that's what we're up to on these. Graph the 2 lines. And again, this doesn't become guess and check and plug in numbers and stuff. That'll become a strategy we use, but not for these. So your job is going to be over here on the back is to graph these. I did one goofy thing, but I'm not going to say anything. I want to see if somebody catches that later. But I do want to give you a couple of hints. I did a couple of really goofy... Because it's supposed to... Let's fix that. This was supposed to be a fraction that I am now seeing didn't show up either. This is going to bother me. What the heck? So instead, we are going to fix it. I am glad you mentioned that. So on number 3 on the back, my fraction disappeared again. So that should be 2 over 3. Silly man, Hardy, silly man. But number 6, in case some of you don't remember from before, and I'll try to, here, see if I can keep them both in. There we go. X equals 5, you're like, wait a minute, I remember seeing something about this. Which direction would I go to get where x equals 5? Close. Positive, I'd be right. So normally, x equals 5 would be like right here. But if it just says that, I can't do all the other things. So my line, x equals 5, correct, is vertical. And then I'd still graph my other line the same normal way. But I just want you to get a little practice. So you got these 6 here on the back to play with. Graph them, find their intersection if they have one. And then we'll talk about that tomorrow, and we'll do some more of these just to kind of get you a little more practice.